solutions for Math 112. These first two problems, we're asked to find the inverse functions of the given functions. So the way you do those, kind of a three-step process. First, just change f of x into y. So we get y equals e, this mess, to the 4 minus log base 3 of 2x minus 3. And then the next step is to solve this mess. Oh, plus 4. Solve this mess for x. So to isolate the x, our first step will be subtract 4 from both sides. So you get y minus 4 is e to this power 4 minus log base 3 of 2x minus 3. Suppose you could deal with exponent rules at this point, but I think it's easier to just take the natural log of both sides and get natural log of y minus 4 is equal to 4 minus log base 3 of 2x minus 3. And then if you subtract 4 from both sides, we'd be left with natural log of y minus 4 is equal to the negative of log base 3 2x minus 3. Move this negative over here by multiplying both sides by -1. You get 4 minus natural log of y minus 4 is equal to log base 3 of 2x minus 3. And then 3, 2, both sides of the equation gives you 3 to the 4 minus natural log of y minus 4 is equal to 2x minus 3. And now we're kind of home free, just got to solve for x, so add 3 divided by 2. And you get 3 plus 3 to the 4 minus natural log of y minus 4 all divided by 2 is equal to x. So to answer the question, f inverse of x, sure, let's jump up here, would be equal to 3 plus 3 times 4 minus the natural log. I'm going to run out of room. Try that again. F inverse of x is equal to 3 plus 3 raised up to the 4 minus natural log of x minus 4 all divided by 2. Kind of a mess. Different ways you could write this, but something equivalent to this is the right answer. Alright, moving on to the second one. Here's g of x, find g inverse. So first step, change g of x into a y, and we get natural log of x plus 2 natural log of x minus 1. Want to get x all by itself, maybe add this 1 over and get y plus 1 is the natural log of x plus 2 natural log of x. This one's a little bit hard. You got a few options. One way to do it would be using log rules. So you take this 2 and bring it up to this exponent to get y plus 1 is equal to natural log of x plus natural log of x squared. At which point you could use another log rule. Say the sum of logs is the same as the log of the product. So what we get here is that y plus 1 is equal to the natural log of x cubed. Okay, and then e to both sides of the equation will give you x cubed is equal to e to the y plus 1. And take the cubed root of both sides, and you get x is equal to the cubed root of e to the y plus 1. So g inverse of x is equal to the cubed root of e to the x plus 1. Maybe I'll put a line here and say other options. We could have said natural log of x plus 2 natural log of x is equal to 3 natural log of x. All right, you got one of these things and 2 more, so now you got 3 of them. Maybe dot, dot, dot. What would that give us? We'd have y plus 1 equals 3 natural log of x, so we'd probably divide by 3 at that point, and then do e to both sides of the equation. So then we get e to the x plus 1 over 3. Maybe g inverse of x is equal to e to the x plus 1 over 3. Something like that. Let's see, what else could you do? There's a few other options. I guess at this, well, maybe I'll leave it at that. 2 options is plenty for one problem. Maybe I'll say or question mark. Because I'm sure there's other ways to solve these. That's how these logs work. Solve the following equations for x. So we're given this equation. We want to solve it for x. We can take advantage of a log rule. We have the sum of 2 logs here. So using our first log rule, that's the same as the product of x minus 3 and x minus 4. So the sum of 2 logs is the log of the product. So what we have here is log base 2 of, if you FOIL this mess out, you get x squared minus 7x plus 12 is equal to 1. Then if you do 2 to both sides of the equation, we'd get x squared minus 7x plus 12 is equal to 2 to the first power. So that tells us that x squared minus 7x, plus 10 equals 0, which you can factor. We need 2 numbers that multiply to positive 10, add to negative 7, x minus 5 and x minus 2. So we get x is equal to 2 or x is equal to 5. But we should check our answers. If you check x equals 2, we'll have to figure out what's the log base 2 of 2 minus 3, which is the log base 2 of negative 1, which doesn't make sense. So this one is not a solution. But if you check x equals 5, it will work. X equals 5, we get log base 2 of 5 minus 3, which is 2, plus log base 2 of 5 minus 4, which is 1. And we're saying that equals 1. Well, log base 2 of 2 is 1. Log base 2 of 1 is 0. 1 plus 0, in fact, does equal 1. So this one is a solution. So our final answer would just be x equals 5. All right, moving on to the last part. Another mess with logs in it. Strategy for solving it. I don't know, you got a couple different ways you could do it. You could subtract this log base 3 over to the other side. I think what I would do is I'd first take advantage of the log rule over here. I'd say I have the sum of 2 logs. That's the same as the log of the product. So x minus 2 times x. And that's got to be log base 3 of 3. So on the left side, I have x squared minus 2x. And on the right side, I got log base 3 of 3. Now I can do 3 to both sides of the equation and get x squared minus 2x is equal to 3. So x squared minus 2x minus 3 equals 0. 2 numbers that multiply to negative 3 and add to negative 2, x minus 3 and x plus 1. So I get x equals 3 or x equals negative 1. But make sure you check them. If we check x equals negative 1, we'll have to figure out the log base 3 of negative 1 minus 2, which is the log base 3 of negative 3, which does not exist. So this one is not a solution. But I think x equals 3 will be a solution. Let's see, check x equals 3. We got log base 3 of 1 plus log base 3 of 3 equals log base 3 of 3. Log base 3 of 3, maybe question mark. Well, log base 3 of 1 is just 0. 0 plus 1 equals 1. Sure enough, got an answer. That is the end of the quiz.